morning to all of you. I am Arpita Gupta, Assistant Professor in Electronics and Communication Department in IIMT College of Engineering, Greater Noida. So today my topic is Introduction to Number System and Arithmetic. As we all familiar with the word number system, arithmetic, Boolean algebra, logicals. So today same topic is number system and arithmetic. As we know that in digital electronics and digital system may use a variety of different number systems, just like decimal, hexadecimal, octal, and binary number system. A number system is nothing but a group or collection of numbers in a consistent manner is known as a number system. And it is the mathematical notation for representing a number of a given set by using digits or any other symbols in a consistent manner. It provides a unique representation of every number, of every digit, of every bit, and represent the arithmetic and algebraic structure of the figures. And in number systems, we all are familiar with the decimal number system, which has a base 10. Some other number systems in digital electronics are the binary number system with a base 2, octal number system with a base 8, hexadecimal number system with a base 16. So now the next one is significant digits. Significant digits, nothing much. They are the specific digits within a number written in a positional notation that carry both reliability and necessity in conveying a particular quantity. Significant digits are two types: most significant bits and least significant bits. Let us start. We have a binary number 10011. Then the rightmost digit, that is last one is 1 and the first one is 1. The rightmost digit, the MSB, that is least significant digit, and the right one is MSB, that is most significant digit. The MSB and MSB are same for all number system, that is for binary number system, for hexadecimal, for octal, and normally decimal number system. The MSB and LSB are never changed. Rightmost digit is LSB and leftmost digit is MSB. Next one is binary number system. What is binary? What is the binary number system? Binary is nothing which has a base 2 is called a binary number system. It is a number that is expressed in the binary system or base 2 numeral system is called a binary number system. And it describes numeric values by two separate symbols, that is 0 and 1. 0 is for low, or we can say that it is false, while 1 is for high. And according to digital electronics, uh, binary number system is defined as a number that is expressed in the numeral system. The numbers 0 to 10 are in the binary form, like 0 1 1 0 1 1 1 0 0 1 0 1 1 1 0 triple 1 1 0 1 0 0 1 0 1. These all are the binary number systems. If we talk about the 7, which is a decimal number, and 7 convert into binary number, we can write 111. Okay, unlike the decimal number system where we use the digits 0 and 9, 0 to 9 to represent a number in a binary system, we always use only two digits, that is 0 and 1. 0 and 1 are, you can say that digits, or we can say that bits. Next one is binary numbering scale. Binary numbering scale, nothing is binary which has a base 2. And if we talk about the power of binary numbering scale, that is we have a decimal number 0, then power is 2 to the power 0 with the positional value 1, because any number with the power 0 always gives the result 1. If we have a decimal number 1, then its binary power is 2 to the power 1 and positional value is 2. If we have a decimal number 4, then its power is 2 to the power 4 and its positional value is 60. If we have a decimal number 7, then its power is 2 to the power 7 and its positional value is 1 to 8. And in the binary number system, 7 is represented as 1, 1, 1. So now the next one is decimal to binary conversion. How we convert any decimal number into any other number system. So if we talk about the decimal to any other number system, the easiest way to convert this type of conversion is to use the division algorithm. In division algorithm, the method repeatedly divides a decimal number by the base and records the quotient and the remainder. This is the example. We have an example: convert 67 to its binary equivalent. 67 is a decimal number. Binary means with a base 2. So when we convert decimal number into binary number system, we use a division algorithm. Division algorithm is divide the decimal number by 2 till the quotient becomes 0. Just like 67 divided by 2, we get quotient 33 and remainder 1. Again divide by 2, quotient is 16 and remainder is 1. Again divided 16 by 2, we get 8. And this process repeatedly till the quotient is equal to the 0. When the quotient equals to 0, we stop the division and write the equivalent binary number. Now, the question arises, how we write the binary number? We write the binary number not from top to bottom, but from bottom to top. Like this, in this example, we got first remainder 1, second remainder 1, then 4 times 0, and then last one is 1 when remainder 1 when the quotient becomes 0. So the binary equivalent of the decimal 67 is from bottom to top 1 0 0 0 0 1 1 with a base 2, because we convert this decimal number into binary number. Next one is binary to decimal. Previously we convert the decimal number into binary. Now we have binary to decimal number. So for conversion the binary number to its decimal equivalent, we use the multiplication algorithm. Okay. In multiplication algorithm, multiply the binary digits by increasing powers of 2. Starting from the right means 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on. The number of binary bits depends, the powers of 2 depends on the binary digits. So this is the example. Convert 10101110. We have 8 binary digits in this sum. Convert this binary digit into decimal equivalent. What we get? We multiply the binary digits with the increasing power of 2. We use 2 because this is a binary number. Increasing power of 2 from the right to left means 2 to the power 0, 1, 2, 3, 4, 5, 6, 7. And then next one is then to find the decimal equivalent by sum of those products, means the products after the multiplication. We got the product 128 plus 32 841. Now add up all these products and we got the final decimal number 173 with base 10. This is the right. But if we are confused that this is right or not, we again convert 173, that is a decimal number, convert into the binary number, and we got the same answer. Now next one is octal number system. Octal means 8, which has a base 8, is known as octal number system. It uses digit from 0 to 7. It has a grouping of 3 bits or 3 binary digits, which represent each octal digit. It also uses multiplication and division algorithm for conversion to and from base 10. Previously, when we convert decimal number to binary, we use a division algorithm. Same division algorithm we can use for converting the decimal number into any number system, either it is octal, hexa, or binary. But the base changes. In decimal to binary, we divide the decimal number by 2. But if we talk about the octal conversion, we divide the number with 8 because in octal the base is 8. And same process will be doing till the quotient becomes 0 and the answer written as from the bottom to top. Now, octal to decimal conversion, again we use multiplication algorithm with the increasing power of base 8 and then add up all the products and we got the answer. And if we talk about octal to binary conversion, it is easy converting the octal number by substituting the codes. Like we write 6 as 110, 5 as 10, 13 as 011, and then grouping all and write it as base 2. Next one is hexadecimal number. Hexa means 16, and it means the base with a 16 is known as hexadecimal number system. In hexadecimal number system, we use this digits and letters. Digits from 0 to 9 and letters from E to F. It has a grouping of 4 bits represent each base of 16 digits. In hexadecimal number system, we write the decimal number 10 to 15 as A, B, C, D, E, and respectively. Like decimal number 10 is written as A in hexadecimal, 11 in decimal written as B in hexadecimal, 13 in decimal number written as D in hexadecimal, 14 in decimal number written as E in hexadecimal, 15 in decimal number written as F in hexadecimal. The easiest way to identify that this is octal number, this is decimal number, this is binary, this is hexadecimal, is that in hexadecimal number system we have alphabets from A to F. In binary number system there are the 0 and 1s. But if you talk about decimal and octal number, it has a base like this. Now we have to convert decimal to hexadecimal. Same division algorithm is used, but in this decimal to hexadecimal conversion, we use a base 16 because hexadecimal has a base 16, and answer can be written as from bottom to top. Now, hexadecimal to decimal conversion, we use a multiplication algorithm again, but with the positional values with a base 60 from right to left, and then add up all the products what we get and write up the final answer. And if we want to convert this decimal to hexadecimal, then by using division algorithm, we get the same answer for this decimal number. Next one is binary to hexadecimal conversion. The easiest way for converting binary number into octal conversion and hexadecimal number is to use a substitutional code. If we talk about binary to octal, we use 3 binary digits, and if we talk about binary to hexadecimal, we use 4 binary digits. Like this, 0 is written as 4 times 0, 4 is written as 0, 1, 1, 0, like 1, 2, 4, 8. In this substitution code, we put the values. If we talk about 4, then check 1, 2, 4, 8. Means 4 is coming. So, then we get the answer 0, 1, 0, 0. Means 4, pin number 4 is high and other pins are getting low. Now representation of fractional numbers. Fractional number means decimal numbers. If we convert any number, any fractional number into decimal number, what we get after same process is used, multiplication algorithm is used, but after the decimal, we use the division algorithm for the same base. These are the examples for practicing. Now we have this number F9A1BC3 into decimal. This is a hexadecimal number, and convert this hexadecimal number into decimal number. Then what we get? What we will do? We will use multiplication algorithm. But after decimal, we use division algorithm with the base 16. Like this. And we got the same answer. If we convert this decimal number into hexadecimal number, then what we get? Use division algorithm and multiplication algorithm as we do previous.